the term ultra-processed food we're hearing every day. Every week there's a new headline in the paper. Ultra-processed food is linked with increased risk of this cancer, of Alzheimer's, of heart disease, of anxiety, of depression, etc. We see something every week coming out that's quite scary and quite alarmist. And alongside that, we see scary figures like ultra-processed food intake accounts for 60% of energy intake in the UK, in the US, in all these other countries. But it's really oversimplistic. It's oversimplistic because food is so complex, and to just classify food into one category, ultra-processed or not ultra-processed, in my opinion, is very, very flawed. I think it comes from the explosion of what I call med-influencers. So people who have doctor before their name because they might be medical professionals or have worked in another area but have never worked in scientific nutrition research. And part of it comes from this narrative that anything natural is obviously healthy. We do have a problem. We do have a broken food landscape. We are consuming too much unhealthy processed foods. Absolutely, yes, we are. But let's not demonize everything.
Welcome to Saving the World from Bad Ideas. I'm Mark Lynas, and I've had a few bad ideas in my time. I used to go out in the nighttime to destroy GMO crops, and I also opposed nuclear power. But then when I looked at the science, I found I got it wrong. Oops! I've learned the hard way that none of us are right all the time. So now I'm here to challenge the assumptions that we all too often take for granted, because the future depends on us getting it right. My guest today is Dr. Sarah Berry, who's a professor at King's College London and chief scientist at Zoe, the nutrition health company leading the gut health revolution, as they put it. She's an academic leader in nutrition science and has run more than 35 human nutrition studies, including exploring recent topics such as menopause, snacking, and cardiometabolic health. She's often an expert on Zoe's own podcast, which is called Zoe Science and Nutrition, and I highly recommend it for everything from discussing ultra-processed foods to what's the best kind of breakfast. So Sarah, welcome to Saving the World from Bad Ideas.
Great, thanks for having me, Mark. I hope that I will be able to save the world today from at least one bad idea related to nutrition. Let's see.
Well, I'm sure you will. And there's literally dozens, hundreds probably of bad ideas that people have. In particular, we like to bust myths. So let's go through a whole load of topics and see how we end up and whether there's a particular bad idea that you think stands out above all of the rest of them in terms of things that people largely believe, but actually which are completely wrong. I did want to start though, just to place you a bit more and give some context to listeners. What is Zoe? What's this apparently commercial company, but which also seems to be very science-based in terms of the products it sells?
Yeah, so Zoe is a science and nutrition company, and it really evolved out of this idea 8 years ago that we all respond so differently to diet and lifestyle interventions, and that the one-size-fits-all approach, which is what population-based guidance is based on, might not be right for everyone. So, for example, we know that some people are really sensitive to salt in terms of their blood pressure, but other people can have their salt, eat it, and not have an increase in blood pressure. And so we designed a whole series of quite in-depth research programs to be able to collect data at a breadth, depth and scale that's never been done before. This was our PREDICT program of research that's still running. We now have data on 300,000 people. And what this has done is enabled us to collect this breadth of data to tease apart what matters for whom and where there are places where a personalised approach would actually benefit someone's health. And it's very much based around gut health and around the microbiome and our growing knowledge that the microbiome, which is the trillions of species that live in our gut, actually play a role in terms of mediating, in part, how diet impacts our health. And so there's this whole idea that we can deliver personalised advice based on various metrics, simple metrics based on age and sex, but more complex metrics like that unique makeup of someone's gut microbiome as well.
Yeah, we'll get into the microbiome because it's actually a fairly new area of nutrition science, isn't it? I mean, when I grew up, we just thought of food as something you put in and it came out the other end, what was left and so on. We didn't really think that we were in symbiosis with trillions of other microorganisms, which actually really, really matter in all sorts of ways. But before we do that, tell us about some of the products that you sell, because, I can't quite get beyond, there might be a bit of a conflict of interest here between selling something commercially and actually running, scientific studies which are publishing in journals. So how do you resolve that?
So my primary role is as an academic at King's College London. So that's where I run research groups, where we have lots of independent research funding coming from research councils, for example, really focusing on how food structure impacts our health responses, which is particularly timely and relevant to today, where 60% of the food that we eat has undergone some sort of processing that impacts the food structure. I'm in a really lucky position, I think, to have this role at Zoe, where I lead the science that we're doing at Zoe, because despite working nutrition sciences at a university for 25 years, I feel that very much often we do science for the sake of science, that it doesn't actually lead to something that ultimately provides actionable insights and change to an individual. And so what I'm doing at Zoe is leading research that's trying to unravel the complexity of who we are, how we live our lives, and how that intersects with our diet, and deliver advice to people through the app that we have. In the US, it's available as a free app at the moment. Here in the UK, it's available as a paid membership, and there's different tiers to it. So yes, it's commercial. I've also received other commercial funding in the past at King's. And I do think that there is this idea or this narrative, very much fueled actually by this whole UPF argument as well, by some of the key players in the discourse around UPFs. There's this narrative that if there's funding by the industry, it can't be trusted. Well, I think it's really important to say there's very little independent funding coming into universities. As academics, we spend so much time applying for funding from research councils, for example, which is funded ultimately from government. And if we don't work with the food industry or other companies, whether it be Zoe, whether it be the big food industries like Nestle, for example, we're actually never going to make change that actually ultimately helps people's health. So I do think there's the bigger picture here, that there's this distrust that if you're working with industry, obviously your science is not to be trusted. I don't believe that. Based on my own experience, everything goes through very rigorous approval processes, pre-registration of clinical trials. Industry can have very limited input on that. In terms of me having this dual role at Zoe, I think it's actually really fortunate, because it means that I can build on my 25 years experience as a nutrition scientist and actually put something out there that will have meaningful impact. Yes, there's a paid product, which is our app, but also, like you said at the beginning, we also have our podcast. We have lots of other educational materials we put out there. So there's lots of ways that people can benefit from all of this research without having to open their purse.
You also have a supplement which is available, is Daily 30, I think it's called, and apparently I'm being sent a free sample, but it hasn't arrived yet. Just tell me more about it.
Yeah, so about a year ago, we released our first whole food supplement, and it is called Daily 30. It has a diversity of different plants, so 30 different plants that then give a diversity of different fibers, which we know is really important. We know nationally and internationally, people aren't getting enough fiber. On average, only about 5% of people are actually meeting their fiber targets. So it's quite high fiber, but really importantly, the fiber is coming in the form of a whole food. And so it's coming in the form of nuts and seeds and mushrooms, for example. We've made sure that we retain what we call the matrix, so the structure of the food, because we believe this is really important. And again, this is based on the research that I've been doing at King's for the last 25 years. And it also gives a diversity of lots of different bioactives. We know that food is so much more than a simple list of nutrients. We know that on average, food contains about 54,000 chemicals. And so traditionally, we've thought about food in the context of the macronutrients, the fiber, the fat, the protein, the carbohydrate. But actually, it's all of these other chemicals that we know play a really important role in terms of our health. And so by giving in, a very simple scoop each day, not only a nice fiber dose, but also giving this diversity of different plants, we're really leveraging the power of these different bioactives. So you might have heard of words like polyphenols, which have these wonderful antioxidant-like activities and act on anti-inflammatory pathways. And so it's intended to be used daily, to be on top of your food. So, for example, you could add it to yogurt in the morning. You could add it as a kind of crunchy topper to, roasted vegetables or whatever. So it's intended not to replace anything, but as a kind of added bonus each stage of food. What we've also conducted, which I led, is a randomized control trial to look at the effectiveness of the Daily 30 versus a standard probiotic versus another kind of food topper that you would sprinkle on top of your food as well. And this was a clinical trial that, again, was conducted according to good clinical practice, pre-registered, etc. And we found that it significantly improved microbiome composition compared to a probiotic and compared to the control. And it also significantly improved other health outcomes, but really importantly, improved how people felt, which is something we don't measure enough in nutrition science. So improved factors like how well people slept, their energy levels, their mood as well.
I did want to talk a bit more about the RCTs, the randomized control trials, because obviously that's sort of a gold standard in science and it's in medicine as well. And in medicine, of course, you have, double blinded, so that neither side, the participants nor the researchers, know when they're getting the placebo or the real intervention. I mean, it seems that not very much of this is done in nutrition, is it? And also, like, how do you tell, how do you actually get different groups when you're talking about real people? I mean, it's one thing with rats where you can, feed them like all of something. But like, how do you get real people to make dietary changes which can actually identify and avoid all of the different confounders? Because diets, of course, are complicated out of people's lives.
Yeah, it's really, really hard. Running randomized control trials, designing randomized control trial protocols are beset with many challenges. It's not as simple as a drug trial. You can't have a placebo in many cases. So there's lots of different factors that we need to consider. Firstly is how much can we blind it? So it might be that we're looking at a very simple ingredient. So I do lots of work looking at dietary fat, so looking at seed oils, for example. And so I could compare that to butter by incorporating it into a food. So I've done lots of trials where I might feed people different spreads, different breads, different cakes, for example, where on some occasions they're having it with the seed oils in, and on other occasions they're having it with the butter. In that case, there is an element of blinding. But even when you can blind it in that way, you then have the challenge of, well, hold on, what else is changing in their diet? And so whenever you add something in as part of a nutrition trial, often you're replacing something else. And that's why you've got to be really, really mindful about what it is that you're replacing, how you're introducing that food or that nutrient or that ingredient into the diet. And so that's a real skill, and something that I've spent a lot of time perfecting over the years is these kind of dietary interventions. I've now run 35 randomized controlled trials, and it's the hardest part of the trial is how am I going to make that dietary modification and be able to be sure that the outcome that I'm seeing that's changing is due to that dietary modification rather than something else has changed.
And you actually care, right? Because you're not just doing this for marketing purposes. You actually do want it to work in almost like a medical way, right? So, because I imagine a lot of what's on the packets of things, probiotic, good for gut health, whatever. I mean, it's not like that's tested in gold standard RCTs, is it?
Absolutely. The biome study that we did to test the Daily 30 was tested in a randomized control trial. And all of the other trials that I've conducted at King's have been to answer a hypothesis, have been to answer a question, are seed oils better than butter for us? Most of the time, this funding has come from independent funding bodies like research councils. So we have the BBSRC, for example, or they might come from charities. Sometimes they come from organizations. But it's driven by a desire to answer a really important question related to how diet impacts our health. It's, as an academic, we're not there to drive sales to any products. We're there to understand underpinning mechanisms, how we can improve the food landscape, what changes we can make to improve people's health. And yes, it's really challenging. The other big challenge that you alluded to as well is, who do we recruit? And again, that's really, really important when you're thinking about running a clinical trial related to diet. Who you recruit is one of the most important factors as well. Are you going to recruit males or females? Are you going to recruit people that are slightly metabolically unhealthy, so you've got a better chance of detecting a difference? What's your main outcome? If you're interested in blood pressure, do you want to recruit people that have slightly elevated blood pressure, or do you want people with normal blood pressure? How will you recruit enough people that are representative of the population? And this is really challenging because research funding is very limited. You cannot run a very tightly controlled dietary study in thousands of people. It's just not possible. Well, not possible within the kind of funding that most people get. And so quite often we have to make very hard decisions about, okay, are we going to recruit a population group that we know that we're likely to see a difference so that we can show proof of principle? And then after that, we can go on and look at the wider population, how it actually plays out. And so we work very hard at deciding who we're going to recruit, but also how we're going to recruit. And it's one of the really soul-destroying parts of research often is trying to recruit people, trying to recruit that right demographic, and also trying to keep them motivated to make the dietary change or eat the food or ingredient that you've asked them to consume for whatever period of time.
So RCTs are one thing. What about how else do you measure scientifically trends or relationships between diet and health? I mean, in the wider population, and do that in a rigorous way?
So our gold standard is the randomized controlled trials. There's also other ways that we can monitor people. So we call these epidemiological or population-based studies. So we can very simply just look at a point in time at a large proportion of the population and say, okay, what are they eating? What is their health outcomes or their blood pressure or their cholesterol levels? That gives us a first indication or a first hint that there's some sort of relationship there. We can also do epidemiological style studies, or we call these often population style studies as well. And this enables us really to get a first hint that there's something going on. And so what we can do at the kind of lowest level is look what we call cross-sectionally. So we can look at a given point in time at a rate of a disease and a certain exposure. So in my case, it will be looking at a dietary exposure. So I might be interested in looking at how much seed oils people are eating or how much butter they're eating and what's their cholesterol levels or what's their rates of heart disease. Now that gives us an indication if there's a relationship. The problem is that there's loads of other things that are going on at the same time. Yes, we can use statistical approaches to try and somewhat account for that, but you can't fully account for everything else that might be going on at the same time. Then what we can do is what we call longitudinal studies. And these are studies that where we follow people over a period of time, and there's big cohorts out there. So you may have heard of some of the Harvard cohorts, like the Nurses' Health Study, for example. And these are studies where we follow people over a number of years, and at regular time points, we ask them questions. We might do measurements of things like blood pressure, cholesterol, and other kind of biospecimens that tell us lots about their health. And by monitoring them longitudinally over that period of time enables us to go to the next step where it's not just this clue of an association, but that actually there is something going on a bit more here, that actually as we see people's levels of seed oil increase, for example, we're seeing a lowering in those people of their cholesterol. Yet as people over 10, 20 years are having more butter, those people are tending to have an increase in cholesterol. Again, there's lots of other confounders. What else is changing in that 20 years? Not only their age, not only their body weight potentially, there could be loads of other things that they're exposed to. And so that's why we try and go to that final level of randomized controlled trials, where we have an idea that there's something happening here. Again, let's use butter and seed oils as an example, that, hey, there's something going on where seed oils might be protected, butter might be unhealthy for us. Let's test this in a randomized control trial. Let's recruit a proportion of people. Let's get them to consume for a certain period of time a diet high in butter, for another period of time a diet high in seed oils. Let's take measurements pre and post. We've exposed them to these different interventions, and let's look what's changing. And also let's look at the mechanisms, because that's really important as well, not just to see the change, but to understand if there's a plausible underlying mechanism as well.
Thank you for that detailed and very useful explanation. I think people will be interested actually about what you found, particularly with butter and seed oils. I remember there being some kind of controversy about seed oils, particularly in the US, where the crazy clowns at MAHA, Robert Kennedy Jr. and all of those anti-vax lunatics were trying to get McDonald's to switch back to beef tallow or something like that because they said that vegetable oil was poisonous. I mean, what does the science say that you found on seed oils versus animal fats?
So I'd love to summarize the totality of the evidence. And I think this is really, really important, because one thing that we haven't touched on is the final kind of icing on the cake, so to say, above randomized control trials are what are called meta-analysis, where you can look at all of the different randomized control trials that are out there. So I would be remiss to only talk about what my studies have found, given that my study might find something different to other studies if I studied a very specific population or a very specific type of seed oil. I also probably need a bodyguard after talking about this. The last time I spoke out about seed oils, I got 4,000 hate messages. And I even got an email from someone asking, how does it feel to be the most hated scientist in America right now? Because I dared to question the narrative that seed oils are toxic, because the totality of the evidence very clearly shows that they're not toxic.
Wow. Producer Rob told me about this, that you were on some big podcast in the US. Just give us the details of that, because I think it's fascinating.
So I went on to the Diary of a CEO Stephen Bartlett podcast, and we did some myth busting, and I love myth busting around seed oils, partly because I've researched in this area, partly because there is a wealth of misinformation, unfortunately, around seed oils. And having broken down all of the arguments as to what the seed oils are toxic, people say, versus what the evidence shows, there was a massive backlash, and I was inundated with quite mean comments. I was called an industry shill, and for the record, I've actually never taken a penny from the seed oil industry or the fats and oils industry. I was asked, well, what do I know? Because they've read a book by some ex-TV star who has written all about how seed oils are toxic, but my 25 years in nutrition science is irrelevant. And yeah, I got lots of hate emails as well around this. But what it's done is it's actually motivated me to speak out more about the misinformation, because there is so much misinformation, not just on seed oils, but lots of other areas as well.
Maybe that's a good candidate for our bad idea that you're busting. But I wonder where the narrative comes from. Do you think it's naturalistic fallacy that animal fats are something our grandparents ate and that's all fine, whereas seed oils are sort of processed and refined from modern agriculture? I mean, there's always a narrative which underpins why people are much more likely to believe a certain thing, isn't there?
Yeah, so I think it comes from a number of areas. I think it comes from the explosion of what I call med influencers. So people who have doctor before their name because they might be medical professionals or have worked in another area but have never worked in scientific nutrition research. And part of it comes from this narrative that anything natural is obviously healthy, and this narrative that butter, with the cows grazing in these beautiful fields with buttercups, is natural for us, and yet seed oils have gone through this terrible processing by the food industry, are evil and out there to kill us. And you see terms like bleaching and deodorization, etc., which are processes used in order to refine, clean, and make stable the seed oils, but that they do not do any harm to our health. So that's one of the narratives that is out there. There's also the narrative that seed oils are inflammatory. So seed oils contain a particular fatty acid in them, which is called linoleic acid. It's also known as an omega-6 fatty acid. So it's a polyunsaturated fatty acid. And what we know is if you look at the theoretical biochemical pathway, this particular fatty acid can be converted to another one, which is called arachidonic acid. Sorry to get technical, but it's quite important here. And upon certain stimuli, arachidonic acid can release mediators that act on pro-inflammatory pathways. So when you look at it written down on paper, it's then quite plausible that you increase your intake of seed oils, therefore you increase your intake of this omega-6 polyunsaturated fat called linoleic acid, and whoa, you're going to suddenly get more of this other fatty acid and all of these inflammatory mediators. That can happen in a petri dish. It can happen in a mouse at supraphysiological doses under certain stimuli. It does not happen in humans. There are meta-analysis, and remember, these analysis of many randomized control trials. There are meta-analysis of more than 35 randomized control trials looking at either seed oils or this particular polyunsaturated fatty acids that show that when fed to humans, they do not increase circulating inflammatory markers. They are not inflammatory. But it's all very well to put on your Instagram page a picture of this bare-chested man in a supermarket munching away at this, big bit of butter or beef, and then show this like scary biochemical pathway with all of these inflammatory mediators. yes, fine, it's a correct pathway, but it does not happen in humans. And the totality of the evidence consistently shows people who consume more seed oils are healthier. They have lower cases of all-cause mortality, meaning death. They have lower rates of cardiovascular disease and so forth. But again, it's this narrative as well around food processing being evil. And again, these kind of scary terms are put out there. The other big problem that we have, and this takes us back to what we were talking about around scientific evidence and different types of scientific evidence, you often see these beautiful figures where you see this line chart showing that as our intake of seed oils has increased, so as our rates of all of these scary diseases, cardiovascular disease, type 2 diabetes, obesity, cancer, and so forth. And they showed that over the last 50 years, look, seed oils have increased, so has all of these scary diseases. Yes, that's correct. But what else has changed in those last 50 years? You know, our food landscape is beyond recognition. Plus, about 60% of the seed oils that we consume are in these heavily processed, unhealthy foods that have got loads of other nasties in, that it's not the seed oils themselves that's the problem. And so it's a great example, I think, and I often use this for the students I teach at King's to show how on social media you can present a very plausible argument around a food, a nutrient, and an ingredient and its relationship with health, which is actually totally and utterly wrong if you take that little bit deeper dive into the evidence.
Absolutely. I mean, you mentioned processing and ultra processing a few times, and having watched a few Zoe podcasts, there's a lot of talk about processing as if it's always, I don't mean to be oversimplifying, but as if it's a bad thing, right? Ultra processed foods are bad. Now that's clearly has to be simplistic. That can't be true in and of itself. But how do you navigate this whole conversation and debate about ultra processed foods? And tell us where the concept originated from and how they're generally classified.
Yeah, so this is a big topic, and the term ultra-processed food we're hearing every day. Every week there's a new headline in the paper. Ultra-processed food is linked with increased risk of this cancer, of Alzheimer's, of heart disease, of anxiety, of depression, etc. We see something every week coming out that's quite scary and quite alarmist. And alongside that, we see scary figures like ultra-processed food intake accounts for 60% of energy intake in the UK, in the US, in all these other countries. But it's really oversimplistic. It's oversimplistic because food is so complex, and to just classify food into one category, ultra-processed or not ultra-processed, in my opinion, is very, very flawed. Now, the term ultra-processed came out from a classification system that was created in Brazil. It's called the NOVA classification system, and it categorizes food into 4 categories. So you've got your unprocessed, your processed culinary ingredients, and then you've got this worst category, which is called NOVA 4, which is your ultra-processed food. We call it UPF for short. And this classification is based on the extent and the purpose of processing. And so if it falls into NOVA 4, or if it's classed as UPF, ultra-processed food, it is decided upon based on how much it's processed and the purpose of that processing. It was never designed to look at how the processing itself impacts our health. And that's the biggest flaw to this, and it's so oversimplistic. And it's really difficult to know, well, is that food ultra-processed, isn't it? And not all ultra-processed food is bad for us. And I think this whole narrative that 60% of our energy is coming from ultra-processed food, I think is really unhelpful. And I think it's unhelpful for a number of reasons. Firstly, because we know that food processing serves a really important function. It makes the food shelf stable. It makes it safe to eat. It also can significantly reduce the cost of food. So analysis has shown that a processed version versus a least processed version of a food within a food group, so let's take breads, for example, there is on average 50% difference in the price. So if you take a heavily processed yogurt versus a minimally processed yogurt, on average, the heavily processed will be 50% cheaper. And so we also need to make sure that when we talk about ultra-processed food, we're not demonizing it all in such a way that, you know, for those people who can only afford the processed version, we're therefore creating more of a disparity in health as well. And I think the biggest problem is that not all processing is bad for us. And I think this is where the term UPF is really unhelpful. So you could have, for example, peanut butter. And you could have 3 different types of peanut butter. You could have a minimally processed, so in the UK, something like pip and nut, which is basically ground peanuts, and then you've got a little bit of salt. You could have something that's in the kind of middle ground, like a Sunpat peanut butter that we have here in the UK, that's got a few emulsifiers and a couple of other things in it. Still, I think, quite reasonably healthy to have. Then you could have on the other extreme something like the Reese's peanut butter that you can get here in the UK and the US and many other countries. If you look at the list of ingredients, it's excessive. There's so many ingredients, additives, emulsifiers. It doesn't resemble the food it's come from at all. Now, that Sunpat, the one in the middle, and the Reese's would both be classed as ultra-processed because they happen to both have some sort of additive in. But their health effects are hugely different. And the reason I wanted to use this as an example is because much of the evidence that's out there that we see these scary headlines saying ultra-processed food are killing us, accounting for all of these deaths, are based on evidence that uses very crude dietary assessment tools. So typically in nutrition research, what we will use when we're doing these big population studies is food frequency questionnaires. So we might ask someone as part of those food frequency questionnaires, do you consume nut butter? That's about as detailed as it would ever get. That's not going to tell us, is it the pip and nut that's really healthy for us or the Reese's that's really unhealthy? It might ask, do you consume bread? Again, you could have this really healthy rye bread, or you could have a terribly unhealthy white bread. And so a lot of the evidence that's out there, when you actually break it down to food groups, we actually see that it's mainly food groups like sugar sweetened beverages or processed red meat that's driving a lot of this association. And so we need to therefore take some of these scary headlines with a bit of caution. However, Mark, I do think it's really important to caveat that we do have a problem. We do have a broken food landscape. We are consuming too much unhealthy processed foods. Absolutely. Yes, we are. But let's not demonize everything. And I think the way to stop demonizing everything is by understanding what it is about food processing that makes the food less healthy or more healthy. And that's what I've spent much of my 25 years looking at dietary fats and seed oils, but also looking at how processing can impact the healthfulness of a food.
Fascinating. Probably the removal of most of the fiber as well in most ultra-processed foods. I wanted to ask particularly about, vegetarian and vegan alternatives to so-called, natural meat, as in defined as edible parts of an animal, according to the latest EU thing, where they're trying to ban the use of burger and sausage on alternative plant-based packaging. And of course, they also get demonized, in particular by the meat industry, for being ultra-processed. I mean, it's the most obvious thing to slap on them. You see a lot of this in the US now in terms of the pushback against alternative proteins. And, and of course, I'll ask you whether you agree on this. We need to move people away from having such meat-heavy diets towards more plant-based alternatives. And of course, that's environmentally crucial to free up large areas of land for rewilding and ecological restoration, which is currently used to feed livestock. So what's your take on that whole issue?
So I think putting aside animal welfare and the environmental side of things and thinking from a health perspective, I think, again, it's quite nuanced. I think that meat alternatives are a fantastic option for people who have been reliant on meat and would struggle to transition straight to a vegetarian diet. And so I think it's a great stepping stone for many individuals. And there's been some nice research showing that by having that as a stepping stone, it enables people to reduce their meat intake and transition more to a vegetarian diet. So I think that's one element, the behavioural side of things, because we have to remember that what we eat is so much part of our upbringing, our culture, our social setting. It's really difficult to change that behaviour. And if you've been brought up where you're kind of that 2 veg, potatoes and meat kind of household, just changing overnight to beans is not going to happen. So I think for that kind of setting, it's a fantastic option. The meat alternatives is such a huge area in terms of they are so different. So one meat alternative burger versus another meat alternative burger could be hugely different. You have ones that are based more, for example, on mushrooms, so kind of fungi, for example. You have other ones that might have some soya protein and might just be full of terrible things or, in them. So I think it's very difficult to say, okay, absolutely meat alternatives are better or worse than meat itself, because it depends on the type of meat alternative. On average, meat alternatives do tend to be slightly higher in salt, but they tend to be slightly lower in saturated fat. But it's so dependent on the individual meat alternatives in terms of health outcomes. But we do have a problem that we cannot continue to feed our growing nation in the way that we currently eat if we continue to be reliant on meat. And so I think it's a great stepping stone in the right direction. Yes, if we can make them in a way that preserves either the original food matrix or that ensures that they don't have too many additives and emulsifiers or too much salt, for example, in them, then, obviously that's going to be better for us.
Yeah, I ask also because, there's a lot of debate about whether vegan diets are, fully healthy or not. I see at Zoe, you promote cheese and full fat yogurts and oily fish and things like that. I mean, that sort of tends to the conclusion that actually you can't get all of these nutrients from a fully vegan diet. So what's the science say on that?
So this isn't my area of expertise of vegan diets. I can give you kind of my top line opinion, having worked in nutrition science for so long. So if planned appropriately, I believe you can get all of the nutrients you need from a vegan diet. But the nuance here is that if planned appropriately. So I believe to get preformed, very long chain omega-3 fats that you would get typically in oily fish is really important. Your body can convert some of the shorter chain versions. People often talk about a fat called alpha-linolenic acid that's in flaxseed, for example, but you convert that at very limited rates. So this is an example where actually if you can get the preformed version, which you can get from fish, then, that's a real advantage to not having a vegan diet. But this is where if planned appropriately, there are algal supplements that have that preformed version, but they're expensive. They're not accessible to everyone. And so I do think it's quite difficult sometimes because I think there's a lot more thought that needs to go into it and there might be an added cost. There is a current obsession with protein, and there's a current obsession, particularly in the US, about protein and getting your protein from animal-based foods. We know that protein from animal-based foods is what we call a complete protein. It contains all the essential amino acids that you need. We know in plant-based foods, so pulses, seeds, for example, we know that yes, they do contain protein, but they don't contain the amino acids in the same ratio that there is in meat. And so again, this is where you just need to make sure you're planning it a bit better. You can get all of your protein needs. You can get all of your essential amino acids. You can get the right amount of essential amino acids from plant-based foods as long as you're getting a diversity. So you need to make sure you're having whole grain sources of protein, nut sources of protein, pulses and bean sources of proteins. If you're mixing those different sources, then you will still get all the nutrients that you need from a plant-based diet, in my opinion.
Maybe that's another bad idea. We need more protein because protein is, as you say, it's like it is the big obsession, isn't it? And it's not just for people who are going to the gym and for young guys who are trying to bulk up. I mean, you see protein on everything now. However, unhealthy in order to, well, I guess, as a marketing scam.
So, two things that shock me when I go to the States that I think are a bad idea are restaurants that now have signs outside saying seed oil free, because there is this obsession with seed oils. And when you go into the restaurant, you have different areas, and there is an area, if it's like a sandwich bar style restaurant, for your protein source. High in protein. You go to the supermarket, high protein bars. Now, yes, we need protein just like we need fat in our diet, but actually nearly all of us get enough protein. Very few people are deficient in protein. Just following a normal diet means that we get enough protein. Most of us actually getting more protein than we need. Not that there's
even if you're going to the gym and even if you want to bulk up.
So if you're going to the gym, you want to bulk out. If you're postmenopausal, slightly older people, yes, you need slightly more protein, but not to the extent that some of these influencers are saying, in my opinion. And whilst there isn't a risk of going moderately high protein to your health, there is a real risk that by adding that protein into your diet, you're displacing something you need more. And that's what we've always got to think about. When you add something in, what are you taking away? And a lot of protein sources, unless you're getting them from the nuts, the seeds, the pulses and whole grains, a lot of protein sources come from sources that are very low in fiber. What are we deficient in most countries? Fiber. So only 5% of people are meeting the fiber requirements. This is what we need to be doing. So another bad idea is that we're not focusing on fiber enough. If we could increase our fiber intake, we would significantly reduce our risk of many chronic diseases, from cancer to cardiovascular disease and so much more.
But I mean, fiber doesn't taste nice like a steak does, or have the mouthfeel of fats, does it? So, like, how do we answer that question?
That's a really good point. And it's something that I'm working on with my kids to make sure they increase their fiber and find it tasty. There are lots of fiber sources that can be tasty. So nuts, seeds, pulses that I've mentioned, but just incorporating them into your everyday foods. My kids love spaghetti bolognese. I sneak in pulses that I just blend up and put it in so that it's snuck in some extra
like a few lentils or something, right? A few red lentils.
Just like lentils, sneaking those in, for example. There's lots of ways that you can sneak things in, but, just encouraging our kids to eat fruit, eat vegetables, going back to the basics.
Yeah, I made some whole wheat spaghetti yesterday, and it just isn't as nice. It has this kind of bitter taste to it. And I thought that I take your point about fiber, but it is probably one of the hardest things. Listen, I want to talk about the microbiome, because I know that's a real central part of the work that you're doing. I'm not sure how to get to this, but it didn't used to be a thing. Like, for how long has it been a thing, and how did it become such a big thing?
So I would say microbiome became a thing in the last 10 years or so. There are many new areas of nutrition that have become a thing in the last 30 years. So 30 years ago, we were very much at a point in time where we thought that our responses to diet, lifestyle, everything was in our genes, that we were predestined to be as we are due to our genes. We actually know now that only about 20% of how we evolve in terms of our health is due to our genes. So our risk of cancer, cardiovascular disease and so forth, most of that is only accounted about 20% due to genes, which is really empowering. I'm a child brought up in the 70s where I was told, well, it's all down to your genetics. Actually, it's not. It is largely under our control. So 80% on average. Obviously, it's different for different people. Some people might have a very particular, unusual genetic, makeup. But for most of us, 80% of us, in terms of our disease risk, in terms of, how we will go on to age, develop, is down to modifiable factors. And these modifiable factors are our diet and our lifestyle, and how they impact our body. We now starting to understand is partly mediated through the microbiome. And this is an area that I think, has exploded, particularly in the last 10 years. We still are learning so much more. So the microbiome is the trillions of bacteria that live in our gut. And what we know is that the bacteria can impact how a food impacts our health. And so it's an area that we're focusing on a lot as Zoe. So we know that there are certain species that are associated with certain health outcomes. We know that some people might have certain species that are linked with lower blood cholesterol or...
These are species of microbial organisms living in the gut, right?
Yes, correct.
Because I've seen you market something called the Zoe Gut Shot. And I thought, how does this, I presume it's got live microorganisms in it. Like, how does it get through the stomach without being fried by stomach acid?
Yes, that's a really good question, because what we know is that when you consume what's called a probiotic, which is live bacteria, a lot of it is destroyed. But there's this whole area called postbiotics, which is like the dead material that these bacteria produce seems to also have an impact in terms of our health. And so we can see this from evidence from supplement trials. So this is where people are given either a placebo or a particular probiotic in a capsule form, where you then see a change in their gut microbiome and also a change in certain health outcomes.
Tell us a bit more about how the gut works and how the microbiome actually affects overall body functioning, right? Because my dad has Parkinson's, and I think I read somewhere that dopamine is actually produced in the microbiome. So there may even be a link with the microbiome and some of these chronic diseases too.
There's so much we don't know about the gut microbiome because we're only just really understanding how important it is. We know that the gut microbiome can produce certain chemicals, and it can produce chemicals locally that act locally in the gut, but chemicals that also can have effects everywhere else in our body. We know that food modulates partly what chemicals the microbiome might produce. And we know that many of these chemicals, dependent on the type of bacteria there, can have favorable impacts. So one of the most important chemicals that these bacteria produce is something called short-chain fatty acids. And short-chain fatty acids can have a really important effect in terms of maintaining the healthfulness of our gut. So they're very protective against, for example, colorectal cancer. They might also act on inflammatory pathways in a beneficial way and so forth. It's actually really complicated how the bacteria act in terms of diet. And I think a really nice example I could give you is related to menopause, because this is something we have done some research on. So what we know is that if you supplement people with soy isoflavones, and so this is a particular chemical that's found in soy that acts like an estrogen chemical. So they're also called phytoestrogens. When you supplement someone with soy isoflavones, what happens is the soy isoflavones bind to the estrogen receptor and they can reduce your menopausal symptoms. But we know that it's really variable between individuals. And we now know that some people contain particular bacterial species in their microbiome that can convert the soy isoflavones to a really active form that binds really tightly to the estrogen receptors. And what it does is it produces this particular chemical called equal that binds really tightly. And so people that have these species that are able to convert soy isoflavones into this really active form called equal have a 75% greater reduction in menopause symptoms when they're supplemented with soy isoflavones versus someone that doesn't have that particular species. And so I think that's a really great example of the power of the microbiome, but also to show how variable our responses are. So just because my friend who's perimenopausal might say, wow, I had this new isoflavone supplement and look, my symptoms have gone. They might have that species that enables them to create this particular potent chemical. And yet I might try the same supplement, have no improvement in my menopausal symptoms, and it's down to our gut microbiome. And we're starting to see this in so many different areas now. And I think that's what's quite exciting. I would say not everything is due to our microbiome, because I know that, we do have to be mindful that food, diet, lifestyle, acts in ways that is also independent to our microbiome. But it seems to all be playing quite a fundamental role, which I think is exciting. And I think the future holds a lot of potential here.
And how do you measure your microbiome? Does it mean a poo sample?
It means a poo sample, and you can measure it lots of different ways. At Zoe, we use something called metagenomic sequencing, and this is conducted by a professor who heads up a big team in Italy at Trento University who undertakes this. How it's done, the readouts they get blow my mind. It's beyond my grey matter to fully understand it, which is why you need people who have expertise just in that area to then interpret it.
I also wanted to ask about organic foods, which were a big thing maybe 10 or 15 years ago, and I think have receded somewhat. But obviously the environmental movement was always busily promoting organic. And the supposed reason for this was, that they weren't using artificial pesticides. And obviously that meant that they're getting lower yields. And, there's all sorts I don't want to get into the whole organic versus conventional debate. But in terms of diet, was there ever any evidence that organic foods were better for you in terms of dietary health?
So this is another area that isn't my main expertise. Top line, and I'm sorry, Mark, I know I'm quite often saying it's not my expertise, but I think any good scientists will put their hands up to say when it's not something they're an active researcher in. My top line view on organic is that it doesn't mean it's healthier for you, that yes, it might have lower levels of pesticides. So for example, if you take oats, organic oats will have lower levels of glyphosates. but the level of glyphosates in non-organic oats is still very low. And unless you're having kilos and kilos of oats every day, I don't think it's enough to warrant any concern. I think in terms of the nutrient profile, there's very limited evidence to show that organic or non-organic, it is different or one is superior than the other. In some instances, non-organic might be superior because of preservation of certain parts of plant, for example. In other instances, organic might be better. So I would say the jury's out in terms of what is better health-wise, nutritionally, between the two. If you are worried about pesticides, then yes, the levels will be lower, but I believe that the levels within most foods are of concern.
Thank you. And every time you caveat your response by saying it's not your area of expertise, you rise in my level of scientific credibility, because that's exactly the sort of thing you should say if you're a proper scientist. So thank you for that. And it doesn't detract at all. I'd quite like to go back just to how science works on this, because I think there's one of the other myths is that they keep changing their minds. Like, first margarine was good for us, then it was butter, and coffee was stopped cancer, and now coffee gives you cancer, or was it the reverse? And people just get kind of very cynical about diet and health because it just always seems to be changing. And it is obviously very complicated, but I mean there are certain things out there which we can say with a fair degree of confidence, it seems. So, like, how do you address this issue?
I think it's a really important problem in terms of public trust. It's a problem because also we're very cautious as scientists. And as you've seen, even for me to say today, we often talk in very cautious tones. It might be, maybe, association. We don't talk in bold tones that you see a lot of people on social media talk about. Also, our food landscape is changing. Food is changing. So margarine 50 years ago was packed full of trans fats, which was created using a process that the food industry used called partial hydrogenation. Trans fats are really bad for us. So yes, 50 years ago, margarine was really bad for us. The food industry no longer uses the process of partial hydrogenation. Margarines, or spreads as we call them now, do not contain trans fats. They contain healthy seed oils that are processed in such a way that I believe they're healthy for us. And so you could have a headline in a newspaper saying, oh, the scientists have changed their mind again. Margarines are healthy for us. They told us in the past they were unhealthy. Yes, they were unhealthy in the past because they had trans fats. Now they don't. The other issue that we have is there's lots of different ways of interpreting the evidence. And there was a study that came out, it was probably about 10 years ago, and they'd looked at saturated fat compared to other fats. And the next day, there was on the front cover of one newspaper in the UK and on the front cover of another newspaper in the UK, two headlines related to this study. One of them was saying saturated fats found to be healthy. The other one saying saturated fats found to be unhealthy. I mean, not word by word.
They were both right, were they? That would be typical science if they were both right and just
they were both right.
Nuance. Oh no, really?
They were both right, and the reason they were both right because it's instead of what, and it was a study that had looked at saturated fat replacing trans fats, which we know is really bad, or replacing polyunsaturated fats or monounsaturated fats that we know are really good. Now, when you compared saturated fat to trans fats, saturated fats came out better for us, because trans fats are just so bad. When you compared saturated fat to the mono or polyunsaturated fats, saturated fats came out worse for us. So actually, they were correct headlines from the same study, but it's confusing people. And this is where it becomes really difficult. And this is what creates that mistrust as well. I don't have the answer to how we get around that. As academics, as scientists, we need to communicate with the media a lot more. We need to communicate on social media as well. We need to put ourselves out there. It comes at a risk. It comes at a risk to the fact that also we are very cautious. But I think it's so important. And I think in the world of the discourses happening around ultra-processed food, it's becoming more and more important because the arguments around ultra-processed food are so polarized. You have certain personalities like Chris Van Tolken, for example, who's fighting a really good fight. But unfortunately, I think it's demonizing far too much food. And then you have certain scientists, nutrition scientists, who are so anti the term UPF that are therefore creating confusion. Well, are they good for us? Aren't they good for us? And this is why I think it's really important as scientists, we say to people, okay, here's what the problem is. When you process a food, this is what happens. You change the nutrients. Heavily processed foods tend to be higher in salt, sugar, saturated fat. They tend to be lower in polyphenols. They tend to be lower in fiber. They tend to have additives and emulsifiers. But also, what else changes when you process a food? You change the food structure. You change the way, therefore, that your body metabolizes it. You change the way you absorb it. You change your hunger signals. You change the pace at which you eat it. And I think this is where it becomes complex, but it's actually really important that we try and find a way to kind of cut through some of the miscommunication and educate people. And I mean, this is something that I'm very passionate about because I spent a lot of time researching how food structure is changed via processing and can have a subsequent impact on our health.
Yeah, because structure is really important, right? I mean, it's not like, because there's various supplements out there like Huel, and I won't ask you to comment on particular commercial products, but like they just add together all of the chemicals and all of the different ingredients that might have been in a meal in powdered form, and you mix it up with hot water, and that's supposedly a meal, right? But I was thinking, well, I'm not chemophobic. I believe in science, so surely that is the same as a meal. It's nutritionally, 100% equivalent. But something is lost there, and that's the structure, is it?
Absolutely. So when I think about what impacts the healthfulness of a food, so how a food impacts our health, I think about three factors. I think about the nutrients, so fat, protein, fiber, carbohydrate. I think about what are those other 54,000 chemicals that are in the food. But I think lastly and mostly, what about the structure of that food? Because the structure, and we call this the food matrix, modulates how those chemicals and how those nutrients will impact our health. And so I can give you a couple of examples from my own randomized controlled trials that I've run. So I've run trials, for example, where we feed people whole almonds or we feed them ground almonds. So these are two foods that have identical back of pack labeling. These two foods have identical ingredients. All you've done is change the structure. So with the ground ones, you finely ground them. So you burst all of the cells. So all of the cell walls are broken. So all of the fat and nutrients inside those cells is released. And by the way, cell walls is what fiber is, which is why fiber has a really important structural role, not just as a powder to add into your diet, but actually the structural role it plays within a plant. So then you've got your whole almonds. And what we did is we fed to people on one occasion whole almonds, on another occasion the ground almonds, and we looked at various factors. We also fed them over a period of time to look at how much of the calories are absorbed from them both. When you consume whole almonds, about 30% of the calories are excreted compared to almond flour where it's all absorbed. And this is because the fiber, which is the cell walls, remains largely intact. So when you eat those nuts, and this applies to many foods, you break up some of the cell walls, but the cells of almonds are tiny. They're about 10 microns. They're smaller than a grain of sand. The point at which you swallow most foods is a particle size of about 1 millimeter. And we've done this. We do lots of these chew and spit studies. So I get people at the point at which they're about to swallow, they spit out what's in their mouth.
I love it. Wow.
Yeah. They honestly, Mark, they're disgusting. I've looked at people's poo, people's wee, people's blood.
I want your job. It's so nice.
Fortunately, I have wonderful researchers that do it now, but I've done my time in the lab doing this, right. I tell you. And there's something very intimate, actually, when someone's spitting. Anyway, we've analysed these chew and spit samples, and they're about 1 millimeter. So you're swallowing particles about 1 millimeter size. So within that, you've got hundreds and hundreds of intact cells where the fiber wall is protecting them from digestion. So what's happening is, yes, you do get some more digestion in the gastrointestinal tract, but they're absorbed really slowly. They're absorbed slower down the gastrointestinal tract, which has more of your fullness receptors. So it's got more GLP receptors lower down the gastrointestinal tract. So it's feeding back saying, whoa, I'm fuller because it's being absorbed lower down. And you're getting a lot of calories excreted. Yeah, on the back of pack labeling, it's 100% almonds. It's the same fat, the same protein, the same fiber, the same carbohydrate. We see the same with porridge. I've done a study where we fed people large porridge and then we just literally ground it down to smaller particles. you see 100% difference in some of the gut hormone responses between the large porridge and the small porridge. You see a 50% difference in the post-meal glucose response, so that blood sugar response, with the smaller particles giving a bigger peak, which we know is less favorable because then you feel less full for longer, etc., compared to the big particles. We see a difference again in where it's absorbed in the gut. But again, these two foods would say they are identical in terms of their composition. And this is why structure is really important. And one of my favorite nutrition studies of all time was actually one that looked at this in relation to the structure of the food, how full people felt, and how fast they ate the food. And this was a study that was done in 1977. It was published in The Lancet. It was one of the first nutrition studies to be published in The Lancet because nutrition science back then was considered the poor man's science. Unfortunately, it still is somewhat. And they fed people 50 grams of carbohydrate, either from whole apples or apple puree, where they literally just pureed the apple, or from apple juice. The whole apples and the apple puree had identical nutrient composition. The apple juice had the same amount of carbohydrate, but had the fiber taken out. So you've got the whole apples that's got the intact fiber. You've got the apple puree that's got that fiber kind of cell wall element broken down. Then you've got the apple juice that's had the fiber taken away, but they've all got 50 grams carbohydrate. And so you've got these three foods that are all with the same amount of carbohydrate. But what happens is that you consume the whole apple lots more slowly. So they looked at how fast people consumed it. And what they saw was that the whole apple, people are consuming about 3 times more slowly than the apple puree. And then the apple puree, they're consuming more slowly than the apple juice. They're rapidly drinking the apple juice. They're then consuming the apple puree and then the whole apples. What this results in is differences in feeling of fullness later on, as well as differences in the circulating blood glucose response. So in this study, what they did is they asked people, come back the next day and I want you to consume these in exactly the same time. And so when they asked people to consume them during the same time, so consume the apple juice, the apple puree and the whole apples in 15 minutes, they still saw this big difference in people's feeling of fullness, that people having the whole apple felt twice as full as those people consuming the apple puree, even though essentially it's the same food. And the reason that this is important and relevant to what we're eating today is because it is the texture of the food that is modulating the speed at which we're eating it, but even independent of the speed, how we metabolize it and our feelings of fullness. And this is really important because a lot of processed food is changed in such a way that the texture is changed. So a lot of processed foods tends to be soft. Soft food we eat a lot more quickly than hard food. And we know again from clinical trials that the faster you eat your food, the more calories you consume, the greater your chances are of obesity and metabolic ill health. And there's some lovely trials that have shown that if you can reduce the speed at which you eat your food by just 20%, so slow down your breakfast from 10 minutes to 12 minutes, for example, subconsciously, without even thinking about it, you would reduce your energy intake by about 15%. And I love this because it shows the power of how you eat rather than just what you eat, but it also shows the subtleties that we need to be thinking about when we think about food processing, that it's not all about that evil additive or emulsifier, that the structure and the texture of the food that's been changed through processing has a big impact. It has an impact because it changes how much of the nutrient you absorb, which we know from the almond work, how quickly it's absorbed, which we know from our porridge work. And it also changes the speed at which we're eating and our metabolic responses and so much more.
Wow, that is amazing. And what a tour de force. Thank you. Unclear, though, whether we should have the bad idea of food processing being bad or food processing being good, because the answer seems to be it's complicated.
The answer is it's a double-edged sword, is what I would say, that food processing, in my opinion, is not bad as a whole, but that we have to be very mindful of how much the food is processed in a way that might negatively impact our health. And that if the food structure has been destroyed, if it does have additives and emulsifiers that we believe are harmful to us, then yes, that's been processed in a way that is unfavorable. but that not all processed food is bad. And actually, we've done a body of research at Zoe where we've looked at how much of the food that we're eating is processed in such a way that we do think it's harmful. And instead of seeing that 60% of our food is harmful, we see that it's about 20% of the food that's processed would fall into what we call a high risk category. And this is using this new Zoe processing score that we've developed that incorporates all the features that I believe are important in terms of how processing impacts our health. So features like what kinds of additives are in there, not just does it have an additive, but what types of additives, how the food structure has been changed to impact the rate at which we eat the food, and also is that food hyperpalatable? Does it have a mix of nutrients that we know encourage us to overconsume that food?
So you're replacing the NOVA classification score with this?
Oh, we'd love to. In our app, we're using the Zoe Processing Food Score. We spent the last year developing this, and it's based on what I believe is most important when we think about food processing, how it relates to health. We've just finished validating this from our Zoe Predict cohort. So in thousands of people looking at the relationship between how much of the food they consume that would fall into this high risk category using our definition, and how that relates to health outcomes versus NOVA. So yes, I would love that.
Okay, well, maybe we'll have producer Rob. You're not allowed to talk, but can you nod? Say whether is the bad idea of ultra processed foods being bad? Is that sufficient? He's given us a nod, so I think we're good to go. So thank you again, Sarah Berry, for joining us on Saving the World from Bad Ideas. As I say, it's been a tour de force, and we'd love to have you back some point. But for now, thank you very much.
Pleasure. Thank you for having me.
Thanks so much for listening to Saving the World from Bad Ideas, a We Planet podcast. We Planet's a movement of citizens and scientists dedicated to defending the science and solutions we need to save the world. Please do subscribe and share a nice review. It helps us spread the message. We'd also love to hear your feedback and suggestions at our email, podcast@weplanet.org. Please also join our podcast mailing list and we'll let you know when a new episode drops. Just go to savingtheworldfrombadideas.org or weplanet.org/podcast right now. See you next time.